Hello, good morning. How's everyone doing? Hello, how's everyone doing? Can you hear me?
Yeah.
Okay, great. Okay, I hope you all had a good Labor Day weekend. To pick up where we left off, we were previously talking about how to analyze the motion in 2D by breaking it down into the X and Y component. So if you throw something in the air and follow a parabolic trajectory, the X direction is really a horizontal constant velocity because nothing is changing the velocity in the X direction. The Y direction will be a free fall. And if you eventually have an upward velocity, that velocity will decrease, right? And then will increase as it goes down. So today, let's continue to look at one more example. I will go through the process relatively quickly, just remind us of what we did. And then I want to talk about, we'll talk about relative motion. We might not be able to do circular motion, but we can certainly finish relative motion today and talk about circular motion on Friday. Okay. So here we have an example of a parabolic motion. Now, for example, if you were asked on a panel, let's say if you a science panel, advisory panel on evaluating some techniques they try to do in sports training, or imagine if you were watching a movie or some kind of action movie that they have this play, then you may be able to evaluate this using your physics knowledge to see whether that is reasonable or not. So for example, you are looking at such a scenario, have a football field goal kicker, and they can kick the ball. Let's say what they target at is 30 meters per second and an angle of 30 degrees with respect to the ground. If the crossbar of the goal on the other side is 3 meters off the ground, how far do you think this kick needs to be? How far is it from the kicker to the crossbar? Okay, so we need to set up our coordinates to draw a picture. For example, if you want to set up your coordinates so that to the right is your positive X direction and upward is your positive Y direction. I'm going to put the origin where the kicker is. Okay, so that's 0, 0 on the ground, 0, 0, X equals 0, Y equals 0. So let's look at the motion in the Y direction. So we're looking at the motion of the football, of course, right? So there are 2 points, initial and final. Initial is at the ground, the final is you're making off the crossbar of the goalpost, which means you are at 3 meters above the ground. So what is my Y initial? My Y initial is here at the ground. It's going to be 0 meters. And what is my Y final? Y final is when the football make it over to the other side. And what is Y final? Anybody?
3 meters.
3 meters, very good. And my Y initial velocity will be the perpendicular components pointing upward. That is your V naught times sine 30. Remember, that is the sine is the opposite side, which is the Y components divided by the hypotenuse. So that's V naught Y. So V naught Y is V naught sine 30, that's 15 meters. So if I plug into the equation, right, for the position y equals y naught plus v naught yt plus 1/2 at squared. So that is the equation we use when it's a constant acceleration. So you had said the y final is 3 meters, y initial is 0, v naught y is 15 meters per second. And since I had defined upward to be positive, so my acceleration will be negative 9.8 meters per second. So plug in this numbers in, you get actually 2 t values. You solve this equation, you get the 2.8 seconds or 0.22 seconds. So in this case, which second should we use to calculate the distance of the travel of the ball? Should we use 2.8 seconds, you said?
Yeah, sorry.
Yes, and what about the 0.22 second? Does that have any physical meaning?
That's when the ball goes from, after being kicked, hits 3 meters for the first time.
Ah, yes, they're very good. That is the symmetric parabolic curve. So that is your time on the other side. Obviously, you're interested on the second half of the parabola when the ball is at 3 meters again. Very good. So with that in mind, we'll take the 2.8 seconds and calculate how far it is that the ball travels. And if you multiply that simply by the velocity in the x direction, right? The time, velocity times time give you distance. Now velocity in the x direction is simply v naught cosine 30, 26 meters per second. And you calculated your total distance traveled in the horizontal direction to be 26 times 2.8 seconds. And that is 72.8 meters. So now you have your result. It's often a good idea. I mean, as far as this particular problem is concerned, right, our job is done. But in a more of a real life problem, you would want to evaluate whether your results make sense or whether this is a feasible plan. You can change it to yards because a lot of times we were talking about the dimensions units of football field using yards. So this is a 79.6 yard field goal. If it were to happen, you can check the history, and the longest field goal is much shorter than that. So you might make your recommendation saying something. This is probably unrealistic because it's much further than the furthest that ever been made.
What's the 0.22 seconds again?
That's 0.22 second is when the football is at 3 meters above the ground for the first time. So it's on the rise. It is still being going up higher and higher. So at some point it's 3 meters above the ground and it's going to the highest point, and then it falls off until it reaches 3 meters above the ground again.
Okay, I see.
Yeah, so it's like somewhere here when the ball is here. So that's 0.22 seconds. Yes, thank you for Marco said longest field goal was 64 yards in the professional football. So that's much longer than what we had, much shorter than what we had calculated. Now if you were looking at this, you would make a recommendation. All right, so moving on to talking about relative motion. I think the word relative, it pretty much is very self-explanatory. We all have experience on this. Sorry, let me get rid of this little annotate. So for example, if you were, this is a person walking on a train, and the train is traveling with respect to the ground, 30 meters per second. You're walking on the train, and relative to the train, you can walk for 1 meters per second. So if you had the experience of walking on those walking belts at the airport, right? That belt travel at certain speed, and if you're impatient, you will want to be able to walk a little bit faster, so you will walk on the belt with certain velocity. So as a result, your velocity relative to the ground would be the addition of the two, right? 30 plus 1 is 31 meters per second with respect to the ground. Okay, so what you just did, that little math here can be represented using this a little more formal math equation, but don't be intimidated by this. this is exactly what you just did. So we did the, okay, person relative to the ground. In this case, let's say A is a person, C is the ground. So A relative to C is A is a velocity A relative to B plus the velocity B relative to C, right? So you can insert any B as you want. In this case, our B is our train. So what we just did, expressed in terms of words, is the velocity of U relative to the ground is equal to the velocity of U relative to the train plus the velocity of the train relative to the ground, right? So that's V A relative to B plus V B relative to C. And you can insert as many as you like. So you can say if you are at the same time throwing a ball relative to yourself, and then you can calculate the velocity of the ball relative to the ground, then will be the ball relative to you, you relative to the train, and train relative to the ground. So later on, we will see an example about that, but we're only dealing with this 3 different velocities here. Okay, so this is a bridge question you have just seen already on your Achieve site. Here you have this moving sidewalk. It's kind of like what we had at the airport. There's a girl stands on it. So it's moving together with the belt relative to the ground at 2 meters per second to the right. The dog is moving relative to the belt at 8 meters per second to the left. So what is the speed of the dog relative to the ground? I'm sure that you, even without learning physics, we can probably figure this out, right? Because we know that intuitively, you have been carried backwards by the belt, right? So you cannot go as fast relative to the ground. So it's not going to be 8 meters per second. It will be 6 meters per second, but to the left-hand side. So if you wanted to do this a little bit more rigorously, we can use the equations we had just showed you. What it will look like is the dog relative to the ground, right? So it would be the dog relative to the ground is equal to dog relative to the belt plus belt relative to the ground. Since there are different directions, you can decide a positive direction here. Let's just say to the left is your positive. So the velocity dog relative to the belt would be 8, the positive 8 meters per second. Belt to the ground is in the opposite direction, so we're gonna say -2, right? Overall, they add up to be 6 meters per second. So that is your speed of the dog relative to the ground would be 6 meters per second. So I think that one we should be able to get fairly quickly. There's another question. It's fairly similar, but instead of asking the dog relative to the ground, is the dog relative to the person, to the girl? What is the speed of the dog relative to the girl? What do you think?
I think it's 8 meters per second.
Yes. You might be wondering, okay, we were not giving any information about the girl, but we know the girl is standing on the belt, meaning the girl and the belt are there. It's the same thing in terms of. Yes?
Oh, yeah. Today I have an appointment, right? Oh, who am I speaking to?
Okay, so the person, the dog relative to the girl is equivalent to the dog relative to the belt. It's the same thing. So it's going to be 8. Okay, here is a question from the pre-lecture. I wanted to go through this a little bit more in detail here. It has a language of saying in the reference frame of the red ball, right? So we talked briefly about a frame of reference previously. A frame of reference is sort of just a standing point from the point of view of whose eye. So in this case, you have a green ball and the red ball, they're traveling toward each other. And we know the velocity of the green ball is 6 meters per second due east, so traveling to the east, okay? Now that is that is relative to what reference frame? That's relative to the ground, relative to the earth, okay? And it also tells you about the red ball, which is 2 meters per second, to which direction it's traveling to the west. Again, it's relative to the ground, okay? So which of the graph correct represent the motion of the green ball in the frame of reference, or in other words, in the point of view from the red ball? So we don't really have to calculate, we can certainly calculate the velocity of the blue relative to the red. But we don't have to, because there's some other information we can use here that can already help us pick the correct graph. So in the frame of reference of red ball, obviously the red ball is at the origin of 0, okay? And in the frame of reference of the red ball, the green is to the left-hand side of the red at 12 meters to the left. So the green should be at a position of 12 meters, and we had decided the positive direction is the east direction. That is what the question wants you to do, right? Is to the east. But the green is to the left-hand side of that. So the green's position would be what? Would be positive 12, or would it be negative 12? So if this is 0, x equals 0.
It'd be negative?
It would be negative 12. Very good. So if I look at these graphs, only A and D have negative 12 to begin with. Okay, and now let's look at which of them has a correct slope. All right, so the slope of the xt graph represents velocity. So the green ball should have a positive velocity or negative velocity. Again, we're saying the positive is to the east. So relative to the red, is the green moving to the east?
Yes.
Yes, it is. So which means it should have a positive slope. So only D has the correct positive slope going up. And if you do have a fifth option that is the same as D, except the slope is different, then you will have to use the magnitude of the slope. Well, in this case, the velocity of green relative to the red would have been 6 plus 2 would be 8 meters per second. So the slope would be 8 in the frame of reference of the red ball, because that's the velocity of the green, right? Now, if you do have a fifth option that the slope is different, then you have to figure out which one has the correct slope. And now in that case, they should also give you the numbers so you can figure out which one is the correct slope. But with this problem, then the information we're giving is enough to tell us that D is the correct answer.
I had a question.
Yes.
With that particular problem. Why would it be negative 12 if they're approaching on the same, like on no, one's coming from the east and one's coming from the west, but they're approaching the same, in the same direction. So why would it be negative 12?
The negative 12 describes the position of the green ball. So sorry, I'm trying to use the annotate here. 1 second. Let me bring it back. Okay, so in the frame of reference of the red ball, whoops. Okay, it just work. This is x equals 0. And to the right is positive. So sorry, I'm not using my pen right now because I want to show the animation. So I can only write with my hand. So the to the east is positive. So at this point, the green is to the left-hand side. In this coordinate system, this would be labeled as negative 12, right? So that's why we show at the beginning, the position should be here below the x-axis labeled as negative 12. Does that make sense?
Okay, so then because it's on the other side, on the left side, it's negative?
Yes, yes.
Because we're starting from the red at the origin, correct?
Yes, yes. In the frame of reference, of the red, we take the origin to be the position of the red, and we take the positive to the east. That is what the problem wants you to do. That's why.
Okay, thank you.
So if I had modified this problem to say, take the origin to be at the position of the green ball, well, obviously, then that all will have to change. Yeah, so it will be negative because of the setup of our origin and our positive directions. Very good. Okay, let's look at next one. Where's my mouse? Why? Okay, I don't know why my mouse is gone. But let me see if I can bring it up over here. Oops. I don't know why my slides cannot advance. Sometimes I guess Zoom just kind of freeze on me. Okay, sorry about that. Let me try to get it on my iPad to work. This is might just take a little time. Sorry. Okay, all right, so how do I, okay, I can switch. Let me. Okay. How about now? Oh, still echo.
带孩子学中文研发的。
Let me turn that off.